Hi IB, we're going to begin graphing the cosine function today. So remember your cosine is your x value. So cosine theta beginning at 0 degrees and moving in an anti-clockwise direction around this unit circle. My x values begin at positive 1. So notice what happens to your x values as you take this point P and travel around your unit circle. By the time you get to pi over 2, or 90 degrees, you have a cosine value of 0. And then at 180, you're at negative 1, 0 again, and then here back to 1. So at 0 degrees and traveling up toward 1 and negative 1, we actually begin at 1 for cosine value. All right, let me go ahead and just make my window here. So 3 pi over 2, always in increments of pi over 2, just because it is easy to graph that way. And I can see my zeros. So cosine at pi over 2 is 0. Cosine at pi is now at negative 1. Cosine at 3 pi over 2 is 0. Cosine at 2 pi, we've got back at positive 1. And again, we want to connect these points with a curve because it is constantly changing. They are not straight lines. We do get points in IB for making the graph the approximate correct shape. So please make sure that when you guys are graphing, we have curves and not straight lines. But really what you notice is if I'm just going to connect this to negative pi over 2. If I shifted by pi over 2 units, it would look very much like the sine graph if I stopped at 3 pi over 2. So really I've just taken that sine graph and I've shifted it left by pi over 2 units. So I could say that cosine is equal to our sine graph of theta. However, I've moved left pi over 2, so plus pi over 2. All right. Looking at our maxes and mins, the same. Our maximum is 1, minimum is negative 1. Our amplitude, again, from that principal line up to the max or down to the min, or think about the max minus the min, so 1 minus negative 1 divided by 2, still at 1. And then our principal axis, we just mentioned, similar, exactly the same as sine, y equals 0. And the period, so it will take, again, 2 pi units to return back to the starting point. So the period for cosine and sine are the same, and they are 2 pi, unless it's been shifted at all. So taking a look at this first example with cosine, we have 2 additional numbers here. So we are going to have 2 transformations. And this d value definitely tells us that we're going to shift up by 2 units. So this is going to change our principal axis. Instead of being at y equals 0, we're now going to be at y equals 2. So I'm going to go ahead and draw that in at y equals 2. And then notice we don't have an amplitude change. We don't have an a value other than 1. So we're still going to have an amplitude of 1, but that just means that our max is going to go up to 3 and our minimum will go down to 1. So cosine has not been shifted to the right or left because I don't have a c value, but I do have a b value. So before I begin to draw my cosine graph and think about what that looks like, oops, here our maximum is at 3, minimum is at 1. Let's take a look at the period for a moment. Period is always 2 pi divided by the b value. So for us, this is going to be 2 pi divided by 3. So that means I should finish 1 full revolution of the cosine graph by 2 pi over 3 units. So easiest way to look at this is then to break up my graph in units of pi over 3. So if I'm going to end my graph, my 1 full revolution by 2 pi over 3, that means half of it will complete by pi over 3. And if I want smaller increments, I could look at pi over 6. So pi over 6, 2 pi over 6 would be pi over 3, 3 pi over 6, and then 4 pi over 6 would be the same as 2 pi over 3. So now I have these middle increments so that I can really in detail draw my graph. So here we're starting at 3. I know that I'll be halfway through by pi over 3, and I'll be completed by 2 pi over 3, which means that I hit the principal axis at pi over 6 and 3 pi over 6. Always connect your graph with nice smooth curve, and we've got a really nice accurate sketch of your cosine graph. All right, so we do have two transformations. We definitely were shifted up, so vertical shift, so I'll call that BS, up 2 units. And we also have a horizontal compression. All right, so we actually are faster than the regular period of 2 pi. So we also have a horizontal compression. Okay. Remember that we can also talk about vertical and horizontal shifts using vectors. So I did not have a shift right or left, but I did have a shift up 2 units. So just remember that that's another notation that we can use for transformations in a vertical and horizontal direction. All right, guys, for our next example, go ahead and pause here and see if you guys can at least identify what the transformations are going to be. Notice we have an A, a B, a C, and a D value. Try to figure out where the maximum, the minimum, the amplitude, the principal axis is going to be and what the period is. All right, so I'll fill in along the way, but go ahead and pause and set up your graph. Notice that we do have a different window here from 0 to 225 degrees. So we're not going all the way to 360. See if you can realize why that might happen. And go ahead and try this one on your own. Principal axis is going to be -3, y equals -3 because of the D value. Amplitude is 4 because of the A value, so make sure that you've set up enough space to move vertically from your principal axis 1, 2, 3, 4 units. And there we go. And also down 1, 2, 3, 4 units for your max and your min. So our maximum and our minimum will be now up at 1, 2, 3, 4. So at +1 and down if this is -3, -4, -5, -6, -7. Because the B value is 2, our period is going to be 2 pi divided by 2, which is pi. So for in this example, we're using degrees. So we're talking about 180 degrees here. So that means I should finish one full revolution in 180 degrees. However, I'm also moving, I'll use yellow there, to the right by 45 degrees. So that means my starting point is at this 45 degree mark. So if it takes me, oops, that's supposed to say 90 there. If it takes me 180 degrees, starting at 45, I should finish my first full revolution by the 225 degree marker. Go ahead and sketch this on your own. Let's see how if we match. So if I shift to the right by 45 degrees and it takes 180 degrees to complete one full revolution, I am ending at 225 degrees, which is the window. However, I want to start my window at 0. So I do actually want to go ahead and continue for 45 degrees back to my starting point at 0, -3, just so that I have drawn everything within this window. All right, so I do want to make sure I start at the correct location. I want to make sure I end at the correct location. And I also want to make sure that I hit my correct max and min and have the correct principal line. All right, that will give you guys full credit for drawing a very accurate graph. Identify our transformations. So again, we have a vertical stretch. We have a horizontal. Now what's happening here? If it takes me 180 degrees to complete, so that is actually less time than pi. So again, I do have a horizontal compression. I have a horizontal shift, and I have a vertical shift. Okay. Now again, if I'm thinking about using a vector to represent my horizontal shift, I'm moving 45 degrees to the right, and I'm moving down by -3. So just to recap your sine and your cosine graphs, for sine, again, principal axis goes right through the middle. We start at 0. We hit our max, we hit our min, we come back up to the principal line, which again is 0 unless we've been shifted at all. If it's negative sine, we'll have a vertical reflection, so a reflection in the y direction, and we'll go down and then up. Cosine will begin at 1, so then it'll hit the principal axis, come back up, and if it's negative, it'll start down, come up to the max, and then back down. All right, so this was a recap of our cosine graph and also how it's basically drawn. If you're familiar with your sine graph as well, this one goes hand in hand.